Well, good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Tonight we're going to take another look at the SAT. And if this is your first webinar with us focusing on the SAT, you might want to know that we've actually been doing a few of these SAT-focused webinars actually with both these guys that are joining us tonight. And I will post a link in the chat window where you can find some of our on-demand content because there's been some changes that have come to the SAT over the past, I don't know, year, 2 years. And we've been able to keep you up to date with that. So if you're looking for some of that archived content, I will post that in the chat soon. But thanks for joining us tonight. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough to teach, tough to learn concepts accessible to all my students. I'm excited to be joined by our two panelists tonight, Pat Flynn and Jeff McCullough. Pat's been teaching math for over 30 years. He currently is teaching AP Calculus BC at Olathe West High School in Kansas. He's a 2013 Presidential Award winner for excellence in math and science teaching. He served on TI-Nspire authoring teams and was a writer for the We All Use Math Every Day program, which was in conjunction with the TV show Numbers. Pat's presented at many international, national, and regional conferences in the areas of technology, calculus, algebra, and geometry. So Pat, it's great to have you with us.
Thanks, Mike. Excited to have a good evening tonight.
And Jeff co-founded the TI-Nspire Super User Group with Bryson Perry some years ago. He currently teaches Algebra 2 and AP Statistics at St. Mary's Episcopal School in Memphis, Tennessee. And in 2009, Jeff also received the Presidential Award for Excellence in Math and Science Teaching. Jeff is also an author of the second edition of the TI-Nspire for Dummies book, as well as the second edition of the TI-84 for Dummies book. So Jeff, it's great to have you along with us tonight as well.
I'm just glad the ice melted in Memphis. So,
for sure. Pat, what's the agenda for tonight? What's the plan?
Well, we're going to be using both platforms, the TI-84 and the TI-Nspire. So make sure you've got yours out with you. But like Michael said earlier, this is going to get recorded. So don't be afraid if you miss something. Follow along as best you can, but you'll be able to play a recording to see. But we're going to focus on some pretty good tried and true techniques for the SAT, like finding minimums and evaluating functions, numerically solving these problems, solving systems using sliders, graphing equivalent expressions, and who knows what else we're going to discover as we go through these questions. When Jeff pulled the questions together, wow, the SAT has definitely upped its rigor, hasn't it, Jeff?
yeah, I mean, I think the common complaint you hear from students is sometimes the practice isn't, the actual test seems almost a little bit harder than the practice. So I tried to pull some pretty tough problems for this one.
Yeah. And I guess we're gonna have a drawing at the end. I guess some lucky person's gonna win something. So watch and see.
Stay tuned.
Yeah. So,
Jeff.
Go ahead.
Some of our outcomes, we want to identify strategies you can use with problems. So we like solving problems different ways. We want to be able to use technology, TI-84, TI-Nspire to solve. I hope you get a little bit more familiar with the topics. Maybe you'll even see a topic and you go, hey, when do we teach that? I think that's an important question to ask as a math department. Do we teach it during Algebra 2 or pre-cal? I know sometimes we've changed the order in the way we taught things. Sometimes we teach trig a little bit earlier and so forth for different tests. And finally, be able to access the files from the webinar.
Right.
Awesome. Thanks, Jeff. So one last thing for me, we're going to be using that chat window tonight to send general messages. And if you have any questions for Pat or Jeff along the way, use that chat window, let them know what you're thinking, what you're wondering, and they'll do their best to get those questions answered live. So Jeff is already ready to go. You gentlemen, take it away.
Okay.
Thanks. Well, let's get going, Jeff.
Okay. So problem number one, and this is, again, you'll have access to this PDF. So this is a system, but it's a little bit harder because they add a little few twists here. So it's a nonlinear system, right? And you get a little A right there, right?
Yeah. I don't think in normal class I've ever done something like that.
100%. I mean, that's true. I mean, I don't think I've given my class this problem before either. So, what do you want to start with the TI-84? What would you recommend we might
Well,
do here, Pat?
let's go through the math first, just to make sure we understand what we're
Oh,
talking
that's a great
about.
idea. Okay. So if you solve it by hand here, I guess you substitution, right? You just kind of
Right.
plug in there. You want to order it by degree, right? So x
Correct.
squared, then x, then the constant. And what did you do there? What you do there,
Well,
Pat?
so we're told that it intersects at exactly 1 point, right? So to solve this, it was kind of like it's kind of a weird idea, but like thinking about the discriminant, right? If
Yeah.
we intersect at one spot, if there's an actual real answer, well, then the discriminant should be 0, which it's kind of interesting that it pops up on this question, isn't it, Jeff?
Yeah.
Like,
I mean, it is a weird way. I wonder how many students are going to think, oh, discriminant here. That's the move.
yeah,
But I think we want to train our students to be thinking that way with the quadratic.
absolutely right.
And it's kind of a weird one with the constant is 64 minus a there,
Yeah,
e squared minus 4ac. So
right.
that's kind of strange.
So we just kind of, distribute out, solve, we get x equals -8.
Okay.
Or I guess we should have said a equals -8. Whoops.
Oh, that's
Um,
right. That's true.
yeah. But anyway, -8's our result. And so in math, Jeff, this is kind of what we would ask people to do.
Yeah.
Um,
I think what was interesting for us here, so Pat, I got these questions from the College Board has not just those 8 or 10 tests that they share on their website, but they also have a question bank. And so I got these
Yeah.
from the question bank, and they actually provide answers, but I was a little stunned when I saw what they provided for the answers. So this came
absolutely.
this came from their website, similar to what we just did. Actually, the method, you can see it's very similar, but they didn't use, I think they used AI, don't you?
Yeah, it looks a lot like AI. AI's got some problems with parentheses, which you notice, Jeff, it's missing a parenthesis there, and
Yeah.
not even math type. I know this really hangs you up a lot. Like, why are you using y minus y? Why aren't
Is
we?
it, I have bad eyes. Is that almost y times y? It's just very unclear
Yeah.
to me.
And then they
So,
forgot a parenthesis in the second statement. They really meant the quantity or the parentheses around the -24. And our students, they have a hard time with that. They'll type it in and think, oh, our
right.
answer should be negative. No,
So if a
no.
student is looking at the AI here, the explanation by College Board provides, it's almost going to hurt them more than help them because
Right. And it's
negative
not the way
24,
a teacher
yeah,
would
minus
explain it, right?
4264, that doesn't make sense there.
Yeah.
So
But
I thought that was just really
yeah,
interesting, just to show that interestingly, the answers were correct, but the work was largely incorrect on
and
these
for a
problems.
struggling student, like you said, really tough to follow.
Yeah. So
So
AI is not perfect. We know that as math teachers. We know we're better than the artificial stuff, right?
right. So I think there's a bunch of different ways we could do this, right? I think on our next slide,
Yeah.
we've got a couple outlined to people to think, but I'm sure there's
Okay.
others as well. But,
So which way should I try here?
oh man, if I was a student, I would probably like my students that have difficulty. We were talking about this earlier. They just plug in the value, right? They would graph both of these, but they would try out the -8 in the place of the letter A.
Okay.
And then just let's see if it intersects at one spot, right?
So I'm going to say plus -8.
Right.
Okay. Graph it. And I can't see it very well
I
there.
can't either.
Yeah. So you could go just old school, go to the window here.
Sure.
Maybe make that Y max quite a bit bigger, 35.
Sure. Let's see.
It's not too bad. It does look like it might cross right there, doesn't it?
Right, it does.
And you could always go second trace, find the intersect. I don't know if you do this. You can mouse right or left. I like to plug in a number when I do this form. So I type in
Oh.
1. Oh, wait. Did that work? Maybe not. Thought that worked. What am I doing wrong?
I think for zero, well, let's see. Oh, you got to choose the curves. So
Oh, you have to choose the curve. So
I
press
think the
enter
zeros
and
does.
press enter. Oh, and just guess, and it'll just solve it. That's right. I was thinking of
That's
the
right.
minimum command there.
Right.
So
And we get
6 point,
lucky. First one, right?
yeah. So it does look like it crosses in 1 point there. It looks like to me. We
But
can
like,
always zoom in as well. So if you hit
right.
zoom, zoom in. And on that one, it's really nice to kind of grab and move close to it and press enter so that we'll zoom in a little bit closer, and you can see a much better picture of that guy.
Right. And then like teaching wise, I really like that the sliders either on the 84 or the Inspire. Like they look
Yeah.
great.
Yeah.
Can
So
really
to do
see.
that on 84, you go to apps and the transform app. If you scroll up, it's usually one of the first ones there. And now I'm just going to make one little change here. So the first two equations, you can use sliders, but you have to use variables. And so in this case, I'm going to use the variable A. A, B, or C
Yeah.
are acceptable variables. I think maybe even D.
Mhm.
And so now I'm going to graph that one. Well, I need to zoom out here.
Oh, right.
Okay, so I can see that right now with that A value, let's see. So
Maybe
can
you
I
got to
start
run
to
it
show?
again because you did the zoom. Right.
Continue.
Okay. 3x plus a. Yeah. Oh, there we go. Okay.
I don't know what happened there. Okay, so you can change the A value. You can kind of scroll left or right. And you can see I'm scrolling until like -6. You can see that crosses twice,
Right.
which is one of the answers there. But if you go to -8, there you go.
And I
So
think you can just type the number in too, like type in just 6.
okay, I'm gonna type in 6 and press enter. It jumps to 6. You're right. So you can just plug in a number there. Oh, that's nice. You can
Sure.
actually you can type in -8 and it jumps right to -8. Oh, that's handy.
So I guess a student could just like try all 4 choices and be like, okay, which one's the best?
Yeah.
But really kind of pushing them a little bit on this.
Yeah. And that's typical of some of these SAT problems, right? They're going to push you. They're really going to challenge your algebra for sure.
Right.
Do you want to try the next one or show?
Yeah. Well, let's I think we're
You
going
want
to
to show
do
this?
I think we'll do sliders again later. You want to say you want
Okay.
yeah, let's do sliders on this one too. Sure. Or all
You
right.
want to try the next one or?
Yeah, let's do the next one. I think you're right. Let's do the next one. That's a good call.
Okay. Okay, so this one, it's got a lot of stuff happening. What's the smallest solution to the given equation?
And no choices, right? Like it's a grid in basically, kind of.
Mhm.
Man, smallest solution.
I kind of debated. I don't know if you debated on what my first step was going to be. I was like, well, the left-hand side simplifies.
Right. But then
But
it's like,
you're gonna,
man, life always seems better to kind of get rid of those roots if you can.
yeah. So maybe just square both sides, right? So
Right.
that's nice. Students really have trouble sometimes when they square a binomial. They forget to expand it correctly.
Right.
But there you go. Similar to the last one. So I want my students trained, x squared term, then the x term, then the constant equal to
Mhm.
0. Not too bad to factor that guy, solve it. You get 10 and -3.
Boy, wouldn't it be
That's a
bad to say
small
the
solution.
answer was 10 by mistake if you're a kid? You do all this great work and just didn't read the question.
Yeah. So what's the smallest solution? And so, yeah, that would be terrible and this one is one of those grid-in responses, right? So you've got to actually just write your answer. So
Well, and I was going to say, people may not be aware, like the online, right? When they take this test online, they can actually just type the number in, which is so much nicer than trying to bubble in all those little pieces that it used to be.
And this is confusing if not so much for students, but remember how you didn't used to be able to put a negative number in there, at least like back in the day. And now we can actually type in -3. So
Right.
that's a change.
Well, shoot, 2 ways, huh, to solve this on the calculator.
Sure. So let's try TI-Nspire this time.
Right.
So I'm gonna go to graph page, and I guess I would just, how do you graph them as two separate graphs? Is that your
I
kind of
do. I just graph them as two, like the left side I graph in F1, and I'll graph the right side in Y2, or F1,
I guess
sorry, and
you
F2.
could set it equal to 0.
Yeah, you could.
There we go. And I hit tab to open up the entry line, and then square root.
Right. A lot of kids are like unexpected, like that graph's yeah, that's the way the graph looks like. Interesting.
So what's the smallest solution? So now I don't need to adjust my graphic. I can see that's definitely the smallest solution there.
Right.
And so I think the biggest thing on both 84 and Nspire, students really want to use the trace command to find that intersection point. Have you find that's true?
I have. So I've been trying with students. I'm like, if you're doing the trace command, you might, if it's a nice number, it might work out, right? But sometimes it's not such a nice number. But since this is a grid in, it's probably a nice number. So I've been having some kids actually, Jeff, when they do the trace command, they really like typing in the numbers after hitting trace. Like they'll like look at this and go, I think it's at 3. I think it's and they love seeing it jump right to that.
So menu 5.1. So if you're in trace mode, you can type in, -1 and it jumps, -2 and it jumps. So that is nice. And I'm kind of close there with -3. I might be on it. I don't really know. So what we can do is go to menu. Analyze graph is one way, right? I think my students like this a lot one. So intersection. You can either, it says lower bound, you want to go to the left of that. So you either want to, go to the left of it with your mouse and press enter. And then either go to the right like that, or you can type a number, like I'm going to type in 2 and press enter, and it jumps to that value and makes the bound in +2.
I like that word intersection
and then we get our
too.
Solution, which was -3, 5 after all. And so obviously we want the X value there because we're looking for X, right?
Right.
Not Y.
Right.
So, because that would be terrible if you put 5 there. As your
oh
answer.
My gosh. The 84's got, so we've got another way to solve that too, that numeric solver, which I think a lot of people, at least in our experience, they're not familiar with.
So if you hit the math key, no math teacher wants you to know where the numeric solver is, right? We want them to do math by hand. So it's at the very bottom of the menu. If you hit the up arrow, there it is, right? It's the very bottom of the menu, just hidden there. And there's numeric solver. This is much better than the old solver. I don't know, I wasn't a big fan of the old 84 silver. You had to set it equals 0. This is just friendlier. I like it better.
Right. Yeah. We put in the left-hand side in equation 1, the E1 for equation 1, and the right side in for equation 2. Yeah, the old one, we had to get it equal to 0. There's a whole bunch of other things you had to do.
Yeah, it just wasn't as friendly.
Yeah.
This one, I kind of like it. If you haven't seen the new one like this, it's pretty handy.
Oh, absolutely. And then we have one of those special, like that OK button. You got to press graph, right? It's one of our function.
So it's an on-screen button. So if you hit the graph key right below OK, and then it says solve. So technically right here, it's asking for a guess, right?
Right.
So if I plugged in 5, that means I'm guessing the answer is going to be 5. And usually it's going to find the answer closest to 5. I don't know what the answer is. 10, right? So it found the answer is 10. Is it possible this would have 2 solutions? Is that possible?
Yeah. Yeah, we saw that on the graph. Yeah.
So I'm going to try 1 as a guess and hit solve. -3. So it found the closest answer to 1, which is -3. So you can plug in different values here for guesses and find different answers. So if I plugged in 15 and hit solve, like it's going to find the 10 again, right?
Right. So the closest.
And I'm not sure if this would happen. This sometimes I'm guessing this might be
Oh, not -10. Maybe if I put -15, that might be not in the domain.
Let's see. Oh, we
Yeah.
get an error message. Yeah.
So if you put in something that's not in the domain, 3 times -15 plus 34 is an imaginary number. So it won't let you do that. It doesn't handle imaginary numbers in this setting.
Right.
-10 probably works.
And then we
gives you
get
one of
things
these.
like this sometimes too, right? Where it's this,
Yep.
wow.
I feel like that's just the calculator trying to solve
Mhm.
it on a graph page, and it's really tough to get it super accurate on a graph page, and we just have to go, yeah, that's -3, guys.
Right.
My students seem okay with that. They don't
Mhm.
cause a fit about that.
No, it's a nice one. And it's my students that they like using it when they get to a tough question, like they don't know what to do. In class, we like to see the work, but SAT, the answer, please. Right.
Yeah. And again, this was a little bit tougher because they don't have the solutions there for us. It was a grid in
Right.
response, so
Right.
always a little tougher. I have students, I don't know if you ever tried this. I've had students who guess and check this answer because you'd be surprised how often the answer is between 5 and -5, and they'll just start guessing and plug it in. It's crazy, but it kind of works sometimes.
Well, I'll tell you, if this was the one where they supplied the answers, shoot, that'd be the quick way, wouldn't it? If this was like
Yeah.
multiple choice.
Sure.
All right. Oh my gosh, look at this. This kind of question speaks to my heart, Jeff. Like in algebra, this is like the
Oh.
algebra teacher's dream. Look at this. This is just, and kids just cringe. Like you gotta be kidding me. There's no friggin' way.
It is intimidating. I think even some of our students who are good at algebra, they get to a problem like this. I think they're intimidated by like, oh my goodness, what do I do here? Like they
X
don't
and
never see
Y?
any factoring, maybe.
Oh. Well, let's see the math on. I think we've got it worked
Sure.
out here.
So that first move was really important here on the right, where
Yeah.
taking out the GCF of x, y in that bottom right denominator, because now I see, oh, x minus 8 match. I don't need to multiply both these monstrosities together to get a common factor. I can just get, yeah, like you did, the left-hand side. You just need an xy over there, right?
Correct.
And so, in fact, if I'm doing this
Yeah.
problem, I might even peek at those answers. Do you ever do this?
Oh yeah, sometimes they give it away a little bit, there's good distractors, but you're looking for
If
like a
you look
format.
at the denominators, all the rest of the denominators except for C, they don't have the same denominator. Our denominator is xy times x minus 8, which is what C's is, right?
Wow.
So
Well,
I'm leaning heavily towards C. If I'm in a hurry, I'm picking C right now because I'd be surprised if they didn't have a simplified form of this. Now it's possible they don't. I mean, that happens. But usually you're going to simplify here a little bit.
yeah, then we add them up
I don't know.
and
We'll see what happens.
yeah.
So,
Yeah, you're right.
they actually didn't simplify this as much as they could have, though. Did you see this?
In the
You
very
could take a
beginning,
y
right?
out of the numerator and cancel it with the denominator y, but they chose not to do that. I think that's interesting to me.
Maybe they're thinking about the student that just multiplied a left fraction by the denominator, multiplied a right by the other. Like they're trying to be nice to them. I would have had them cancel out the y's on the right and the x minus 8s and reduce, but it wouldn't have been an answer for us to choose from.
Yeah, so they're trying to I don't know, they just want you to manipulate the algebra and then check the answers. So
Yeah.
is there a way to do this on the calculator? Because it's got x's, y's. This could be hard to
Yeah.
graph that guy.
I think there's a couple ways, right? Couldn't we it is a graphing calculator, right? So I think we could just graph the problem and this would be more of an Nspire graphing, wouldn't it? Because of the
Okay, so
relational.
you're saying that the Nspire can graph something like this?
I think so. We can graph X and Y's. It's a relational.
Okay, so
How do we get there? What do we?
So you delete the equal sign and choose relation.
Oh.
But now, what's our equation? Do we want it to equal 0? Do we want it equal? This is a weird.
Oh, yeah.
I haven't thought about this one.
I haven't either. I don't know if we maybe we should stay away from graphing relational on this
I'm
one.
going to stay away from graphing.
Yeah.
I would say sometimes it works really well, like graphing ellipse or circle works really well.
Yeah.
but this is not really an equation to graph. I guess you could you set the left-hand side equal to the question and the right-hand side equal to the answer? They are going to be
I don't-
equivalent.
So we'd be looking for something where the graph is. This is kind of getting to a kid that like, okay, if they know what to do there,
Yeah, I don't
they're
know.
probably
I
doing.
think the move that I teach, especially I tutor a lot for like SAT and
Right.
ACT, and I tell students if you're stuck and it says the word equivalent, you can plug in values, right? So you can actually
Right.
plug in, like x equals. So I'm going to store some values here. So 3 stow x.
And that store button was by the number 1, was it, Jeff?
Right
Yeah,
next to number 1.
gotcha.
And then 5's my second favorite number. And then alpha y, so you hit the alpha y there. And now I guess I could type in the fractions here.
Oh
So
yeah, we
alpha
could
x
type in the problem.
Yep.
And what's nice is it'll tell you what that answer is when x is 3 and y is 5. Now, did you pick like 3 and 5 because they're just odd numbers, or do you avoid
Small
some
odd
numbers
numbers
like
make the answer pop a little bit better. That's my
Gotcha.
experience. Alpha y.
So it kind of makes
Sometimes-
this question for a kid to be more like just, okay, it's a numeric problem. We're just finding a number.
Yeah. It does take a little bit of time, but you're kind of guaranteed the right answer. So there's
Mhm.
that. And this is going to be one that might be out of reach for some of our students.
But this picking numbers is used like in a lot of other like types of questions
Yes.
too, though, right? So what did
So
we
now
get
I
there?
know the answer should be negative 46 over 15 if I type in one of those answers. 3 of those answers are probably not equal to that, and one of them is going to be equal to that.
I think we got it on the next slide, I think.
Oh, did you actually do it?
Yeah. Hey,
Oh, wow. Oh, that's interesting that D was so close
right.
when you
That
typed it in.
sign.
Oh, you did 3 and 5 as well. Oh, that's so beautiful.
Yeah.
Oh, and you typed it in for all of them and you found out what
Right.
that was?
So Jeff's like showed how to do it once, but we thought to save some time, right? Like, hey, let's just. But what's nice on that
Sure.
A, B, C, D, Jeff, I think you could like, copy down the previous expression and then just kind of change a couple things to make it match
Yeah.
the new one. And
That's true. Once you get that first one typed in, you could do that. And I think you're right, Pat. This is not just for this problem. There's going to be a number of problems where you could use this strategy and really
Mhm.
help out that student who's not very strong in algebra at all.
Hey, I got a question. Let's say some students using this strategy, they do letter A, and let's say the answer to A was negative 46 over 15. Do they need to try out B, C, and D, or do they need to?
Well, that's why I chose somewhat unique numbers there, because I was
Yeah.
trying to make, like, if you plugged in 1, it might work on a
Oh.
couple of them. Usually, you pick somewhat unique numbers like that, and you're going to be okay.
Gotcha.
But
Oh
yeah,
yeah, because like 1 to
technically,
the
you should
third
check
is
all
like,
of them.
yeah,
That is possible, right?
that makes sense. That makes sense.
Let's look at number 4 here. So this one, oh,
Right.
kind of a classic function problem. They love function problems.
Yeah.
Actually, though, this is an interesting problem because they didn't tell you anything about the graph of the original. This is a fascinating one because it's not one that I've seen a lot of function problems, and this
Mhm.
one's unusual to me. Was it unusual to you as well,
It
Pat?
was that transformational, that f of x minus 3. Like I've done those as two separate kind of questions. Like here's a table and figure out f. But the minus subtracting 3 does a little transformational on here, like the union of those two ideas. And SAT does quite a bit of that, don't they? Trying to merge some ideas together.
Yeah. This is going to challenge our students because they don't give you a starting table for this.
Yeah.
So doing the math, I guess the thing that comes first to me, well, I know 3 points on that graph, right? If it's in factored form. So you've got those 3 points, negative 6, 0. Those are the 3 zeros. And I
Right.
guess if you take those 3 points and move them down 3, like the transformation is going to do there,
Mm-hmm.
oh my goodness, that's what it is, isn't it?
Yeah.
I think I see it. Well, no, I don't see it. I got it. Oh, there it is. Yeah,
Yeah, letter B. Yeah.
it's B.
So one nice thing, I guess, is to clue into students like, hey, if they look at that X column in those tables, They're
Yeah.
all the same X value. Okay, where do those come from? Because
Yeah,
like the
because
debate is like, why are we
otherwise it
using
seems
zeros?
nonsensical. Like, why did they choose -6, -5, and then they chose 4? Like, it's not
Right,
even in a pattern there,
right.
So if you don't catch that, this could be a lot tougher problem there. I guess on a calculator here, so you might, go to, go to a graph. It seems like we use the graph a lot.
Yeah, it's a helpful tool for sure.
Hmm.
And then you'd probably just graph the f of x that they gave us, right?
Yeah.
And then what's kind of neat is the calculator also can display tables of values, I believe, right?
Yeah. And I really like it when teachers teach that. I can tell when a student has used a table. Some classes, they don't even show them the table, right? In fact, let's go right to the table. Second graph is table. And there it is. You can see -6 and -5. Whoops, there it is. 0, 0, right? And
Mm-hmm.
so I guess for y equals, can we actually do a transformation here?
Oh yeah, how do you access that y? I don't want to retype all that. I just wanted to do
Okay.
y1 minus 3. How do we get
So
y1?
if you hit the alpha trace command, the F4 menu, there's y1.
Nice. That is
So
so
that's
quick.
kind of like f of x here, right? It's y1. So parentheses. Do I have to say parentheses of x or no?
I
I'm
don't
not
think you
sure.
have to do anything. I think you just do y1 minus 3.
Okay, I think you could say parentheses x and then
Good.
-3. But I'm just going to say -3.
And the key is with
So I
students,
think,
don't do the negative sign, right? Do the subtraction sign.
right? So that's a weird graph. Let me zoom 6 that guy. Oh, there I see it. So you can see
Oh,
the blue graph is the original. You can trace, you can see that. That's the original graph. And then the red graph, it's been moved down. And so
yeah.
if you look at the table, should be a nice view of this. Oh, this is nice, right? So you can see you've got -3. Oh, -3. And if you scroll down to 4, you get -3. They're all
Mhm.
-3s.
I like how the table, that one is red, just like on the graph it was red.
Yes, it's very
Very
nice.
powerful.
You can also do this. I don't know if you ever tried this, but as a teaching thing, when I'm trying to show a graph and a table at the same time, I use this mode sometimes.
Oh, right.
If you go to it used to be called GT on the old TI-4, but it's graph table. And now the key is go to the table. I want you to record this with the table, and I can
Mm,
scroll and actually show. Whoops, there's -6. You can see. Do you see I'm toggling back and forth between those 2 points?
I can on the graph, yeah.
And you can see it toggles over to that 0. So it shows you on the graph visually, and it's showing you the
Mm,
points in the table at the same time. Now, the only drawback with this, you can only show one at a time here,
right.
right? So
But
there it is, like -3 for the y. You have to kind of blue is to the left and red is to the right. The two different functions.
pretty
Uh,
powerful
but
though.
but still pretty nice to see a visual picture of where those points are. I like that
I
mode
do
a lot.
too.
I don't leave it in that mode, but I use it when I'm teaching domain and range sometimes or things like that. It's a teaching move for me, not so
Right.
much a student move, but I like it.
Nice. Let's go on to our next one. We've done 4 problems. We're already 30 minutes in, Jeff.
Sorry about that. These are tough problems though,
They
right?
are. They are.
Oh, so this is interesting. Let's try this one with Inspire here. So it's pretty similar. So I'm going to go to a graph page. And I guess I'll just graph this first one. One thing I notice on Inspire, I don't know if you do this, but always put a time sign on Inspire.
Sure.
Do you do that just to make
Yeah,
sure it
it
knows?
thinks words. Like if you type in the word time, time, it'll make a variable called time. And maybe you
Yeah,
wanted t times I times m.
sure.
Yeah.
So that's oh, you know what I should do?
Oh,
Just,
7.
okay, so,
Yeah,
that's my F3, right? So if I hit
correct.
tab, I guess I can go, so I want to do F3. You just type
Parentheses.
F3, it bolds because it knows what that is.
Right.
Can I just say 7 minus X here?
Or could we use W?
I don't think so. It's going to
No, let's
graph
do
only with
X. Yeah.
X, right?
Yeah, let's do X, right?
So it graphs that function. So it actually, that's kind of a weird one to do. It's not like it's not a typical transformation, the 7 minus x. It's kind of
Right.
confusing there. And so it'll graph that function. And I think show us the table if we need to, right?
Mm-hmm.
What are some of all the possible, where
the zeros are.
So where are the zeros? Is that what we're looking for?
We're trying to find the sum of the zeros, right?
So I see one at
Sum of all the-
5,
Yeah.
one at 7, and one at 13. And I expected 3 of them, so that's probably it. Control T gets you rid of that table. You also could have traced, right? So menu 5.1, menu 5.1, and go. It shows minimum. It'll pop up to say 0. One of the things I like on Inspire, if you press enter, it lays down the point for you.
Hmm.
And you get to 13. Did it pass it? Sometimes it has trouble, that trace command. I had trouble getting all
Right.
those zeros. It's so up and down there. I think
I
it
wonder
just
if you
had,
can you type in the value when you press trace? Would it jump to
sure,
it?
you can type in, was it 5? No,
Yeah.
13. I thought it was 13. Maybe it wasn't.
Yeah, it was 13. It was 7513.
Oh, am I on the right function or not? Here I am.
Oh,
No,
I
if I type
think you were on
13.
the wrong one, right.
That's what it was. I was on the wrong function. And then
Mhm.
5. Yeah, that's what it was.
But this definitely shows like the table was much more efficient to find those values, right? Like we were showing earlier.
A table, when they're integers like that, it definitely
Right.
is more efficient for sure.
And have you found on the SAT, Jeff, that most of the answers are like on questions like this, usually integers, or like 90% of the time, or? Right. Well, I think we got the math up for the next one on this. Oh, I think the ice may have gotten Jeff a little bit. Yep, that's exactly right, Jim. That would be the algebra way of going through that one. Well, let me pull it up while we're waiting for Jeff here. Okay. There we go. Here we go. Easy take the job. And we will do that one. Okay.
You're trying to share your screen, right?
Yeah, I'm just pulling it up here so we can do it while Jeff reconnects here. Sorry about that.
Thank
There
you.
we go. No problem. Okay, so I am going to. All right, sorry about it. We always got technology things. It happens. Let's get to where we were, and then Jeff will reconnect with us. Okay, we were on question number 5. And I think someone had pointed out that the algebra way on number 5 was, replace all the x's with 7 minus w's. I always find it's very helpful to color code things as you go through them. And of course, then those would simplify to be this. And I saw that in the chat. And then we can see what the zeros are. Not too bad on that one. So that was the math on that. And again, Jeff talked about the technology piece that we could graph them, and then we could also do a transform. Now let's look at another question here. This one, number 6. So we're given an equation on the right, x equals 8a times the quantity b plus 9. And on the left side, we have to solve for a. So this is your basic literal equations, right? Let's solve for a literal equation. Well, the math on it's not too bad. We divide both sides and get the a by itself and we're able to come up with our correct answer, which is letter B. Now, Jeff had pointed out that plugging in values is really, really a helpful way of doing this. So let me get my graphing calculator up and we will plug in values. Now, I believe when Jeff did these, he would let one value equal 3 and the next equal 5 to give us a unique solutions, right? Boy, there was a class today. We had quite the class then for sure. All right, so let's see here. Da, 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 da. Let's see, always on top. Here we are. Move this sucker over here. And we will refresh that sucker. Okay, so Jeff goes ahead and he lets, on this problem, he would let the values equal. So he might let A equal 3, perhaps. So we would say 3. And again, it's that store button by the number 1, right? So 3 store as alpha A. So now again, every time I type in the letter A is going to be a 3. And then B, you probably store that as a 5. So 5 store B. So alpha B. So now every time I type in the letter B, I get 5. Now, we have to store a third value, x, right? Now, we got to make sure the math is right. We can't just pick willy-nilly numbers for x. We have to use like, hey, if A is equal to 3, right, we'd have 8 times 3, which is 24. And if B is equal to 5, 5 plus 9 is 14. So then we'd have to do our math real quick, which would be, work this out real fast, 24 times 14. We would then let the value 336 store as x. So these are the pieces that we have, right? Now, what we have to do is find out which one of these things work on our literal equation. So I'm going to just do the letter B because that's when it works out, just to save some time here. So the left-hand side is A. So we're trying to look for when we get an answer equal to 3. So if I type in the expression to the right of that, so we'll do a fraction bar and then do x over 8 times, now B we said, well, I just have to type in the letter B, right? So x times alpha B plus 9, 8, okay, 8 times alpha B plus 9, close the parentheses. Now I've typed in the expression for letter B, the right-hand side of it. Hopefully, we also get the value of A, which is 3. And we do. We would go through all these cases. And like Jeff said, if we're picking unique values, like letting A equal 3 and B equal 5, it works out pretty nicely. And again, you got to make sure the X value you're picking is correct. Now, again, the math that we did, like here's the canceling out, solve it, there it is. But again, using technology, plugging in values, find some nice values for A and B, X is equal to this. And as we try all these out, we find out only letter B is the one that works. Okay, so that was question number 6. Let's take a look at number 7. We're given an equation. The sum of the solutions is equal to K times 4A plus B. K is a constant. What's the value of K?
I mean, again, is this a question you've ever seen before in your math class?
Never. Jeff, welcome back from the ice, from the cold.
Sorry about that.
No, it's all right. Yeah, I've never done that in class. Or, I mean, this kind of question. I mean, how would you do this one, Jeff? I mean, let's say it's math class.
My first thought was factoring, just because they kind of wrote the middle part, but then it's not easy factoring necessarily, but it's a little different. But I think factoring would work. Like I thought the last term is probably A and B there, right?
Right.
And I guess
well, yeah,
the
that
first
is a
term
tough factor. Gosh.
It does work that would work. So, but I agree, it's kind of tough.
And then, yeah. And then some of those solutions.
So now you're adding B over 16 plus A over 4. But this is not, that's equal to K times.
Oh my gosh.
Oh my goodness.
My kids would love
this is an algebra intense problem.
It is. And so we could factor out, oh, k is equal to 1 over 16, of course. So, man, you're factoring on the left, finding the zeros, adding up the zeros, making it equal another function on the right, and then getting a common. There's a lot of math in here, Jeff.
Yeah, there's a lot of math, and they really like that structure of the quadratic. You see how many quadratic problems they've seen here, but this is just taking it up a notch on the algebra. Just reminds me also of a tough pre-cal problem.
Right. So I think this is another one where we could just plug in values again, right? We could let A equal 1 and B equal 1.
Oh, wow.
I think.
Okay, well, let's try it. So what happens if you plug in A is 1 and B is 1?
All right.
What do you get?
So I'm going to save some typing. I'm going to copy
Okay.
this down and let me try that again. Sorry about that. Let's try that one more time. So A equals 1 and then B equals 1. My kids love that copying. Okay, so A equals 1, B equals 1. And then we would just type in the expression on the left and see what we get.
Wait, but we've got x in there, right?
We have x's there too. Oh my gosh. This would be, well, if
Should
A
we
equals
graph
1
it?
and B equals 1, would that give us 6? Would that give, boy, I can't have my here.
I mean, do we use the solver then?
Maybe we, well, do we get a nice quadratic on the left if A is 1 and B equals 1?
Okay, so we get 64x
get
squared
64x squared
minus 12x
right
plus 1.
Right.
Okay, so let's get the, try the polynomial. Go to the apps. Let's try this.
Yeah, so we'll go to
So
apps.
go to the apps.
And the polynomial simultaneous solver.
Usually it's number 9. There it is.
Right. And we want to go ahead and do the root finder, I believe, right? And we would say it's a quadratic. And next. And we just got to type it in, right? So 64. And then you always leave that as a plus sign, don't you, Jeff? Like to make the typing in easier. And then this is a -1. And then we're adding again. And we said A and B are both 1. So 1 times 1 is 1. And we hit solve. Oh, man. That's not helpful. That is not helpful on that at all. All right. These are some tough SAT questions for sure. Well, let's try something different. Let's try this one. Which one has no real solutions? Now, we saw earlier the discriminant that we'd like to try out. But we know, like with things with real solutions, that mathematically we would be like, well, that's when the discriminant is negative, right? It means that you're taking the square root of a negative value. Well, we could go through each of these processes and find out which ones give us negative values, right? And it turns out the only one on the left, right, that works out is letter D. That's the discriminant, right? That gives us an imaginary answer. But what's nice is on the graphing calculator, it works so much better. What I can do is I can go ahead and graph the problem. So I'm going to graph letter D. And then with students, you're like, well, what does it mean that there's no solutions? And some of them are never really sure why that is. Let's get rid of these answers. All right. So I'm going to type in letter D, 5x squared minus 14x plus 49. And if I graph this, now one thing I violate all my big rules is like whenever I'm graphing, I always want to do a zoom standard because a lot of times, like you saw with us earlier, we're zooming in, changing answers, changing the window settings. I always want to do a zoom standard first. And I'm like, gosh, I'm not seeing the graph at all. We did type it in, right? Yep, we did type it in. But if we go to the table, we can see that these values are pretty big, those Y values. So I think our window's just not going high enough. So maybe let's let the y max be, say, 100. Let's see what this graph looks like. We can see that, hey, letter D, when you graph this, it never crosses the x-axis. So there's no real solution. So one thing we noticed when putting this together is that on the SAT, they really like to give you things. If you're going to graph, it's going to be in a somewhat non-standard window, right? It's not going to come out just right. So let's take a look at another problem here. Maybe Jeff will join us for that one. Yeah, so we graphed and found out which one does not cross the x-axis. Letter D was it. Okay, so here's number 9. We've given an expression, and we're said that it can be rewritten as that factored form. However, x, k, and j are integer constants. So they could be positive and negative, but they are integers. Which of the following must be an integer? Wow.
This one,
what do you think?
I mean, honestly, just to start, I didn't know what to do. I was like, I guess, expand that, the binomials, kind of
Sure.
get the form the same.
Oh, we got another one of these grouping things again, right? Didn't we have this
Yeah.
earlier with that linear term?
Yep. I mean, so we know H is 4, right?
Right.
I guess that B is all that stuff, and then K times J is -45. Oh, that's nice.
Now, earlier today, you had said to glance at the answers sometimes, right?
Okay.
I think if we glance at the answers on this, like that C and D kind of pop out to me a little bit with that
Oh, yeah, you
45.
see the 45, don't you? Yeah.
Yeah,
That's a high-end move right there.
yeah,
So if you just kind of manipulate the algebra there to get solved for J,
right,
oh, because J's gonna be an integer,
right.
K's an integer, so it must be divisible by, yeah.
That's it. Not an obvious question, a pretty deep, but this would be a good discussion question in class. And this is on the SAT, right? This is
Right.
oof. Okay. Now
You
I
can
think
see why the students say this is a tough test, right?
right. And then technology wise, man, I'm not sure on that one. I am not sure, but
If
we
you have
like
an
that
idea, we
question a
could
lot.
try it, but I
Um,
don't know.
I'm looking at our time, Jeff. Let's do one more and then jump to the end where we've got that other technology piece.
Okay.
So number 10 here, right? Here's another one. What's the value of A? And we're like, well, math-wise, we would take this and expand, right? Just like, expanding out the previous one. But then we
Sure.
know what it has to equal. And so you'd be like, well, 13A is, I mean, it's kind of like the same one that we just saw, right? So again, pretty good technique to make sure people see this idea of matching. Okay, yeah, a lot similar to it. And again,
What I did,
not as
I actually got the
yeah. So I worked it out. Yeah. So oh
yeah.
yeah. Oh, absolutely. Okay, let's look at one more of these. This one was just like, oh my gosh. In the XY plane, yes. Intersects a parabola at exactly 1 point. So much math on this, and there's so many ideas. Like, we should notice that this equation they're given us is a horizontal line, right? So if we're intersecting the parabola at 1 point, we must be intersecting the vertex. So right there's a nice mathematical content to kind of recall. And then remember, like finding vertices or finding the vertex, really nice way to find the x value is the opposite of b divided by 2a. So we're using our quadratic here, and we come up with the x value equaling b over 8. Now, if we plug that into the function they give us, because I want to find out what the y value is here. So I replace the x's with b over 8. We wind up with b squared over 16. Great, that's the y value there. Now it should equal the y value of the other piece also, right? Should equal the y value of this. So we end up with 9/4 is what that comes out to be. Set them equal to one another, b equals 6. A lot of math there, but again, like we saw earlier, we can do this with sliders really, really well, that the transform app on the 84. So if I go ahead and run that, I'm going to go ahead and go apps. Transform is the last one on the list. I'm going to choose that. And when I go to y equals, I now see that these things on the left allow me to do the transform app. So I'm going to type in the first one, which is, if I solve for y, that would be y equals, I'm going to be a lazy person and say 4.5 divided by 2. We'll make divided by 2, not a decimal point. Make the calculator do that. On the second one, I'm going to type in our equation, negative 4x squared plus, now b, that's alpha b and x. And then plus, oh, that's it. Okay. So now I'm going to go zoom standard to get our window back to normal. Or zoom, let me try that again. Zoom standard. Here we have it. And as Jeff showed earlier, there's our piece. I can do right and left arrows. And I'm going to keep going until it looks like it touches only at one spot. And it looks like b equals 6. What do you think, Jeff?
It's hard to tell exactly. Is it 6 or 6.5? I can't tell.
Yeah, so I think we could do is zoom in further, right? We can zoom in by number 2. And like you said, move that cursor to where the location is that we want to zoom into. Now, I wonder if we go to the table, would it,
that's a good idea.
Show the values that are same in both? And we said B, oh boy, okay, so B was, okay, I got to go back. Our B value was 6. So the Y value, we're looking when the Y value is the same, right? That's what we're trying to find out.
Yeah.
So when is the one? So well, the first one's 2.25, right? So when is that Y value 2 point? Boy, yeah, we're gonna have some decimals in here, aren't we?
Yeah.
Yeah. But the transform app really helps us make some of this crazy math here on the left not as bad, right? It's able to get us to where we need to go. Again, we had a lot more problems planned for this, but the big ones that we noticed, Jeff, were like what the discriminant kind of popped up a lot of times.
Yep. Quadratics, they love those quadratics.
Yeah, and these are some tougher questions to go through, for sure. All right, I'm going to go ahead and do that. All right, Michael.
Thanks so much, Pat and Jeff. Jeff, thanks for pushing through tonight and trying to.
Sorry about all the technical glitches.
It happens.
Those ice storms, they'll sneak up on you. You never know what's going to happen.
Oh, we've had some ice. We were out of school for over a week, so.
Wow.
All right, so we are going to begin wrapping things up tonight. And as promised, one lucky winner is going to receive a graphing calculator of their choice. And tonight's lucky winner is Kenneth Brown. So, Kenneth, congratulations. Start thinking about which calculator you want to get. You got some options there. And I'll be reaching out to you over email soon. To receive a certificate of attendance, go ahead and click the link in the chat window. Also coming in the chat window is a link for the documents that Jeff and Pat used tonight. And those are going to be super helpful because in that documents link are all the problems. And then I don't know how many more we didn't even get to, right? There's a whole bunch in there that are just really great to be able to practice with your students. So make sure you check out both those links. And if you're watching this on demand, copy that link into your favorite browser to receive your certificate. If you need to get a hold of us for any reason, maybe you need to update your calculator or have questions about doing some updates or where to get some apps, give us a call, 1-800-TI-CARES, or send us an email, ti-cares@ti.com. Finally, whenever you leave the webinar tonight, a brief survey will automatically appear in your browser. We love hearing your feedback. And also, it's really important as we plan future online events. So if there's something that you'd like to see, let us know. Huge thanks again to Jeff and Pat for everything they shared tonight and put together for tonight. Thanks so much, fellas. I appreciate it.
It was a
Thanks.
lot of fun.
And thanks to everyone else for joining us tonight. We hope to see you back online real soon. Have a great
Okay.
night.
Joy.